Most AI evaluations stop at accuracy. But when it comes to statistical reasoning, that's like grading a student only on whether they circle the right letter, ignoring how they actually construct the solution. A recent study by researchers at Southern Methodist University pushes past that limit, evaluating 15 current-generation large language models across 90 statistics questions spanning high school to graduate level. Instead of relying on a single metric, they built a multidimensional evaluation framework. They measured raw accuracy, tracked response behavior like explicit no conclusion or missing outputs, applied structural topic modeling to map the latent conceptual structure of the explanations, and used TF-IDF cosine similarity to quantify lexical overlap across the corpus. Accuracy ranged from 55 to 78%, with newer generations generally outperforming older ones. But accuracy alone masks critical behavioral differences. Some models confidently guessed wrong, while others explicitly recognized insufficient information and declined to answer. That distinction is analytically meaningful. When they fitted a structural topic model to over 1,000 explanations, the results were striking. Despite wildly different accuracy scores, every model relied on the exact same conceptual organization. Topics like hypothesis testing, confidence intervals, sampling distributions, and causal inference appeared consistently across all 15 systems. The models weren't lacking statistical knowledge, they were just applying it with varying reliability. To examine how those concepts were linguistically realized, the team computed TF-IDF cosine similarity between every pairwise explanation. This weights terms by local frequency and global rarity, isolating meaningful lexical patterns rather than just counting shared words. The analysis revealed modest but consistent vendor-specific clustering. Anthropic models exhibited tight explanatory phrasing, while OpenAI and Google models showed greater internal variation. Cross-vendor similarity was only slightly lower, indicating that all these systems share a common statistical vocabulary, differentiated only by subtle stylistic fingerprints. The takeaway is clear. Statistical reasoning in generative AI cannot be characterized by accuracy alone. You must evaluate how models structure their reasoning, how they handle uncertainty, and how consistently they apply concepts. As AI integrates into education and research, evaluation frameworks need this same multidimensional lens. Because knowing what a model knows is only half the battle. Knowing how reliably it uses that knowledge is what actually matters.